Line segments, written and presented by me, Jean Legui. Here's legal stuff. A line segment is a small part of a straight line. Here's a straight line. It starts at a point, I'll call it point A, and give that coordinates xa and ya. And it ends at a point, I call it point B, and give it coordinates xb and yb. Things I can find out about this line segment. Like any line, it has the equation y equals mx plus c. Like any straight line, I should say. And m, which is the slope, is the difference in y divided by the difference in x. This is the difference in y, and it's yb minus ya. Here's the difference in x, and it's xb minus xa. So then m is yb minus ya divided by xb minus xa. In this specific case, point A is at minus 5, minus 9, and point B is at 7, 9. So putting those values in, I get m equals 9 minus minus 9 divided by 7 minus minus 5. Or m equals 18 over 12. So the slope m is 1.5. What that means, of course, is for every one it moves in the x direction, it goes upwards by 1.5, and that looks correct. Now I'm going to find the intercept. Just make a bit of space. Okay, I'll pick one of the points, say point A. And since y equals mx plus c, at point A, ya equals mxa plus c. So at that point, I'll substitute in for those values. So 9 goes in instead of ya minus 9. And I get minus 9 equals 1.5 times minus 5 plus c. Rearranging, c equals minus 1.5, which is just there. That's the intercept, the point at which it crosses the y-axis. And that looks right as well. So altogether, the equation y equals mx plus c for a straight line, in this case, y equals 1.5x minus 1.5. Other things we might want to find out is the distance between the 2 points, which I'll call r. When you look at this, it's a triangle, a right angle triangle specifically, and I'll just make that a little bit smaller. We know that with right angle triangles, the area of the square on the large side is the same as the sum of the area of the squares on the other two sides. That's Pythagoras' rule. And there's r, there's the length of the other two sides. So r equals xb minus xa squared plus yb minus ya squared, all square rooted. For my points, minus 5 and minus 9 and 7, 9, I'll substitute in for xa and xb and ya and yb, and I get this. When that comes out, that's 12 squared plus 18 squared, or the square root of 468. So r is 21.63. Distance between the two is 21.63. Another thing we might want to find is the midpoint between the two, that point there, halfway between the two. I'm going to call that x mid and y mid. Now, when you think about it, the x mid is actually the average of the x values. So the average of the x values is just xa plus xb divided by 2. And the y mid is just the average of the y values. So that's just ya plus yb over 2. So that's the midpoint. In summary then, if you have a line segment, it has the equation y equals mx plus c, where m equals difference in y divided by difference in x, or yb minus ya divided by xb minus xa. And c is mx. I've chosen one of the points and just substituted in the values and the m value that I found previously. The distance between the two using Pythagoras is that. And the midpoints are just the averages of the x and the y. So that's that. So that's line segments.